So the last way to solve a quadratic equation, and the way that always works, is to use the quadratic formula. And remember, the quadratic formula, just like factoring, just like the square root property, and just like completing a square, finds the x-intercepts. And that's, of course, where the graph crosses the x-axis. So this equation is set up in quadratic form in descending order, x to the second, x to the first, and then x to the 0, 2, 1, none. And this allows us to bring out the coefficients a equals 2, b equals -6, and c equals 1. And of course, it must be set equal to 0. So we can solve this with the quadratic formula, as this particular equation is not factorable. So our quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this formula allows us to plug in these values into the formula and solve for the values of x. So x equals the opposite of b. If b is -6, the opposite of -6 is +6. Next, plus or minus. Remember, quadratic equations yield 2 results. So we're looking for 2 answers here. B squared. So that, of course, is -6. So that's -6 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a. So let's start simplifying, and of course we're following order of operations. So we're going to do everything underneath the radical first. So 6 plus or minus -6 squared is 36, and keep in mind that this number will always be positive because it is a perfect square. So 36 minus 4 times 2 times 1, 4 times 2 times 1 is 8. So 36 minus 8, all over 2 times 2, which is 4. So keep going underneath the radical. Underneath the radical, 36 minus 8 is 28. And then we need to simplify that radical, and the square root of 28 simplified is 2 root 7. 6 plus or minus 2 root 7 all over 4. Now we do need to go one step further and simplify this particular fraction. And remember, nothing is ever canceled until you factor. So let's factor this numerator. Put it on an index card since I'm running out of space here. So 6 and 2, we can take out a 2. And when we take out a 2, we're left with 3 plus or minus 2, or excuse me, taking out the 2. We've taken out the 2. 6 divided by 2 is 3. 2 divided by 2 is 1. Over 4, which of course is 2 times 2. And because we have factored, we can now cancel those 2's, and we can get a final simplified answer of simply 3 plus or minus root 7 over 2. That, of course, gives us our 2 x-intercepts. And you can see here that the quadratic formula will work, but lots of times it takes the most effort and the most steps. Let's do it again. Solve. 5x squared equals 2x minus 3. The first thing we need to do is put it in descending order and set equal to 0. So let's do that by moving the 2x from the right to the left and the -3 from the right to the left. So we will have 5x squared minus 2x plus 3 equals 0, which gives us our A value, our B value, and our C value. So A equals 5, B equals -2. Remember to keep the sign in front of the number. And C equals 3. So these are the values that are going to go into our quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So let's plug them in and solve for X. X equals the opposite of B. The opposite of -2 is +2. Plus or minus B squared. Take this opportunity to square -2. There's no need to write -2 squared here. -2 squared is 4. Minus 4 times 5 times 3 all over 2 times A. 2 times 5 is 10. Follow order of operations and simplify what's underneath the radical. And that is going to be 4 minus 20 times 3. So 20 times 3 is 60. 4 minus 60. 4 minus 60 is -56. So we have a negative number underneath our radical sign. And when we have a negative number underneath the radical sign, it means we're going to have imaginary roots. So let me come all the way back over here to the left. So we're going to simplify the square root of -56. So -56, remember, is -1 times 56. That's why an I is going to come out. And then the square root of 56, 56 is 4 times 14. So 2 is going to come out, and 14 will stay under. Everything is over 10. So once again, just like on the last one, we're going to factor the top. We have a common factor of 2. Take it out. 2 divided by 2 is 1. 2i divided by 2 is 1i. And then root 14 over 10, which is 2 times 5. The 2's cancel. So x equals 1 plus or minus I root 14 all over 5. 2 imaginary roots. One last problem. 2x over x minus 3 plus 6 over x plus 3 equals -28 over x squared minus 9. This is a rational equation, and the first thing we need to do is get a common denominator. And of course, x squared minus 9 is our common denominator. Its factors are x minus 3 times x plus 3. So ask yourself, just like we do in class, the what's missing question. What is this denominator missing? It's missing the x plus 3. And whatever we need on the bottom, we also multiply on the top to rename the fraction. What's this one missing? X minus 3, x minus 3 on the top. So now, just like we've discussed in class, once you have a common denominator all the way across an equation, you no longer need it. We've used it and we're going to lose it. And now we just need to work on the numerator, which is 2x times x plus 3 plus 6 times x minus 3 equals -28. So follow order of operations and simplify. 2x times x is 2x squared. 2x times 3 is plus 6x. Distribute the 6, another 6x, and 18. And to save ourselves a step, I'm going to go ahead and bring -28 over to the other side, make it +28, and set equal to 0. Got to do that. Combine like terms. 2x squared plus 12x, negative 18 plus 28 is a positive 10, and that is now equal to 0. Now, one thing we can do with this problem to help ourselves out is 2, 12, and 10 are all even numbers. So we can make all of these numbers smaller by dividing away their common factor of 2, which is an integral factor. And we can always divide away an integral factor. We just cannot divide away a variable factor. And this leaves us with x squared plus 6x plus 5 equals 0. So now let's solve this guy. And we're going to solve him using the quadratic formula. So let me rewrite it. X squared plus 6x plus 5 equals 0. Now that we've got it simplified, a equals 1, b equals 6, c equals 5. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you will write the formula every time you use it, you'll know it after about the 5th problem. Let's plug in. The opposite of b is negative 6. B squared is 36 minus 4 times a times c all over 2 times a, 2 times 1 is 2. Underneath the radical, 36 minus 20, 36 minus 20 is 16, which is a perfect square. And in our next video, we're going to find out the significance of the number underneath the radical. And in this case, it's a perfect square. And when you have a perfect square underneath the radical, it means that your expression was factorable, which it is. Factors of 5 that add up to 6 were 5 and 1. We're going to see that in just a moment. So, negative 6 plus or minus the square root of 16, which is 4, all over 2. And now we can simplify here. Negative 6 plus 4 is negative 2 over 2. Negative 6 minus 4 is negative 10 over 2. And that leaves us with our answers negative 1 and negative 5. So x equals negative 1 and negative 5 for the roots of this particular equation. Now, one thing we need to do is look back, since this was a rational equation, and ask, are there any restricted values? Yes, x could not be plus or minus 3. We did not get that. Our answers are negative 1 and negative 5. Therefore, they are valid and not extraneous. That is solving with the quadratic formula.